Okay, so this is week 14, number 2. Once again, we are talking about weak base whose KB value is small and they want to calculate the pH value. So this is talking about weak association, a small amount of dissociation from the base to generate the alkaline compound, which is an OH minus here. Okay, so what is our base here? This is an ammonia. Okay, so let's write the equation first. Ammonia in water. This is a base, so they're going to take the H plus from the water, so they become HNO4. Okay, so there's a ammonium ion plus and OH minus. So that's the equation is going to be. And the one thing that for sure is, okay, we want to calculate the pH, but what we know is pH is 14 minus POH, right? And that's for sure. And then the POH can be calculated by minus log 10 OH minus concentration. So once you actually have a POH numbers, and we can calculate pH from this simple arithmetic equation. Okay, so let's start with the ice problem, establishing the initial change and equilibrium. The initial condition, concentration 0.180. Okay, what's my change? So you're going to lose some, as a weak base does. They're going to convert it into the ammonium, so plus X and the plus X. Okay, so that's the initial, and that's the change that is I'm going to anticipate. And this is an equilibrium, right? So now, actually, I'm going to write it a little bit more. Equilibrium. This is an equilibrium, which is 0.180 minus X. That's a concentration for ammonia, and ammonium is an X, and OH minus is an X. So as we normally do, now we go back to KB, which is your NH3, NH4 plus and OH minus concentration. That is 0.180 minus X and an X square. And since KB is much smaller than 1, which is a weak base, we can see this value shown up here is going to be approximated to be just that and X squared. So that is my approximation. So there was my approximation. X is very small compared to 0.180 mole, which is an initial concentration of base. Right? So that is a initial concentration of base. And then that really simplifies my calculation once more. So X squared 0.180 is, what's my KB values, which is shown up right here, 1.8 10 to the minus 5. Okay, so that will give me, actually this is one of the interesting one. X squared, okay, is 1.8 times 10 to the, this one is 1.8 10 to the minus 1, 1.8 10 to the minus 5. So I know that this is a 1.8 squared 10 to the minus 6. So therefore my X value, which is a 1.8 10 to the minus 3. Okay, just do the square root of this on both sides, and then you'll get these numbers. And then once again, what do I know about the x, the meaning of an x? The meaning of x is concentration of OH minus. So therefore, because my goal is trying to calculate the pH, but the easy one is OH minus concentration calculation. So therefore, POH, which is a minus log 10 OH minus is now minus log 10 1.8 10 to the minus 3. That will lead me to value of 2.74. So for pH is 14 minus POH, 14 minus 2.74, and you will get 1126. Okay, so this is my answer. So once again, the key part about dealing with what is known as a weak base is knowing that this K value is very small, so we can approximate this approximation. So that's the highlight of this to simplify these calculations. Once you do, you don't have to deal with more complicated form of quadratic equation. It's just a matter of taking the square root in each values, and you can calculate this x values, which is once again too small compared to this value, which is known, and you can say OH minus concentration to calculate POH, finally calculate the pH. Thank you for your attention.